How does a guitar string's length affect the pitch? By Ryan Flint. This is my science project. Let's get into it. Introduction. I wanted to conduct this experiment because I play guitar. So I come on to learn more about guitar, and it seemed like it would be an interesting experiment. Next slide. Question and hypothesis. So my question was how does a guitar string's length affect the pitch? And my hypothesis was that as the string gets smaller, the pitch will increase. Research. I did lots of research, and so the next few slides will be this. So you can look over it. If you need more time for each slide, you can pause the video and just read it and look over it. So I'll be moving on to research 2. Here's research 2. Research 3, even more exciting. This one taught me a lot of the equations and some of the other things that, research 4. This one was, it was kind of a simulation that helped show more about sound waves. Sound waves in the eardrum. So most of the other ones just describe like how sound waves work or how a guitar works. This one described to me how sound waves affect your ear and how you perceive the sound, which was helpful. And I think this is our last research page. It told me what hertz actually stand for. It explained decibels to me. So it also gave me lots of pictures, which helped me understand it. Now we're on to variables, constants, and trials. So obviously I've already stated my hypothesis, but my independent variable is string length because that is what I was going to be changing by figuring the different positions. The dependent variable is obviously the frequency of the sound because that's what I'm trying to see how that relates to the independent variable. My constant is going to be the temperature, the tuning, the placement of the guitar. And I will conduct 10 different trials for each and every string. It's quite tiresome. Materials. So obviously I'm going to need a tuning instrument, a guitar, a pick, a computer, a notebook, and a pencil. So if you want to perform this experiment at home, you need these materials. Procedure. So first, obviously, you have to gather all the materials needed, tune the guitar, pluck the high open E string and quick frequency shown on the chromatic tuner. Then, you guys can read, so you guys can read that. It ended up being quite similar to the project that we ended up doing later on in science. But just remember, I did it first. So moving on to our data. Much like research, I did lots of data. So that'll be the next few slides. But first, before I conduct the experiment, I measured the lengths to each fret so I could know the length of the guitar string. So I have the lengths right there. Here's the data from the high E string. So this shows the fret and the frequency. And again, if you need to look at it closer, you can pause at any one of these slides. We'll be going through them fairly quickly. Here's the B string data, the G string data, D string data, A string data, and the lower E string data. Here are the graphs and tables. So on the left, I have a graph, and in the one, as you can see, it shows you the string. It shows you the frequency for each fret. As you can see, it frequency gradually rises with the fret, and the higher E string was obviously, you guessed it, had a higher frequency. The low E string had a lower frequency. So this shows how it starts, when you get to the higher frets, the frequency gets higher, but as you know from the lengths, as you get to higher frets, the length gets shorter. So when the length gets shorter, the frequency got higher. On the right, we have a graph. And what you're probably wondering when you look at this graph is why, for the square, it says frequency of pitch created like the string. It should say the pitch B, but Excel is being weird, and I don't know why it was doing that. So yeah, moving on. Observations and analysis. I kind of already covered this in the previous slide, but basically, as the string length gets shorter, the pitch frequency increases. Conclusion, this was also very similar to my observations and data. So my hypothesis was in fact proven true. So yeah, yay me. Woohoo! There are some factors that could have slightly affected it. For example, if the tuner picked it up wrong, or if my position changed throughout the experiment, or it's also possible that the tuning could have gone down a little bit throughout the course of the experiment. Bibliography. As I said before, I used many resources, and here are the main ones I used. So you gotta give credit, otherwise plagiarism, then you go to jail. Jail's not fun. Then the end. It's all over. If you have any questions, you can ask me, or you can also check out my research paper, which I did, and turned out I didn't have to do. So you can check that out if you have any more questions. Yeah.